Lun Gang. I don't know which devil woke up on the wrong side of the bed to write this question, but it was sent to me on the Lun Gang Reddit page by, I have no idea where they found this, Comfy9801. And if you guys want to submit your own questions, feel free to join the Lun Gang Reddit page, join the community, link is in the description. So the question basically says, an underdamped system step response is observed to follow that equation, shown as the system output, so basically the diagram. Determine and label each axis intersection shown in the diagram. So I guess the first one, the easiest one to work out is where it crosses the y-axis, which is when x is 0. I'm going to be rubbing a lot of stuff out, so I'm not going to label A, B, C just yet. So when x is 0, what do we get? E to the power 0 cos 0, which are both 1. Then we need to set y equals 0. Now that can never equal 0. You can even write as cos 3x over this and times 3 by the denominator and it goes. E to minus 2x is positive though. So we're just solving cos 3x is 0. Now there's no range here. We just want the first negative, the first positive, and the second and third positive. So just go like normal. We're going to do inverse cos of 0, which is pi over 2. Now you guys might know this already, but the cosine function is an even function, meaning that if this is pi over 2, this is minus pi over 2. But I'll show you how you can derive that anyway. So that's pi over 2. We're going to work out the secondary value by doing 2 pi minus this, which is 3 pi over 2. And then to work out the third one, all we need to do is take our primary and secondary and add 2 pi. Well, if we add 2 pi to this, we're going to get pi over 2. And you're not going to do this one because obviously it's going to go out of the range. Yeah, we only want the third one. Now, how do we show that this is minus pi over 2? Well, we take our primary and secondary value and subtract pi over 2. Okay, now if you look at an axis, we want the first negative one, right? Look at my fingers. Subtract pi over 2. Okay, so it's going to come from 3 pi over 2 minus pi over 2. And when you do that, you do get minus pi over 2. Okay? So now we just need to divide all of those by 3, which I'm just going to start putting on the diagram. So we have pi over 6. We have 3 pi over 2 divided by 3 is pi over 2. And our third one, 5 pi over 6. And minus pi over 6. Okay. Right, so that's done. Find I. I is the integral of this function, which is an absolute pain, man. This is basically where we make all our mistakes. Now, I'm hoping that this is not going to be us. Now, there is a trick that I'm just going to briefly, the trick to know if you're kind of on the right line is the denominator. There's going to be a fraction here. If you do Pythagoras to these two numbers, it will tell you what that denominator is. 2 squared plus 3 squared is 13. So I'm hoping I get a 13 in the denominator when I factorize everything out. But let's see what happens. We have the integral of e to the minus 2x cos 3x dx. So this is obviously integration bypass. Cheeky Liddy. I didn't need so much space for this, but we leave the first term. Integrate the second. Now, you would guess sine 3x. Sine 3x goes to 3 cos 3x. We do a third of both sides. A third sine 3x. Then we differentiate the first term, minus 2e to the minus 2x. And this are always the same. So we have 1/3 e minus 2x sine 3x. Minus 2 can come out to make plus 2 thirds of e to the minus 2x sine 3x. Got to do Liddy again. Now you guys should recognize this stuff already as a cyclic integral. It's going to go around in circles. Shout out Post Malone. So Liddy again. Leave the first term. Integrate the second. So we guess cos 3x goes to minus 3 sine 3x to minus a third. So minus a third cos 3x minus, differentiate this, minus 2 e to the minus 2x. These two brackets always the same. So we have minus a third e minus 2x cos 3x. The minus 2 comes out to make plus 2, but with the minus third it actually becomes minus again. So minus 2/3, integral e minus 2x cos 3x dx. So you can see we have that integral, and you could call it I, yeah, because they did define it as I. So to save some space, let's just do that. So this, which is I, equals, and we do that a lot in further maths anyway. So we get a third e minus 2x sine 3x plus 2/3 of this, which is all of this, minus 1/3 e minus 2x cos 3x minus 2/3 I. So I is 1/3 e minus 2x sine 3x minus 2/9 e to the minus 2x minus 2/9 e to the minus 2x cos 3x Why am I bugging? Minus 2/3, 2/9. That's what I wrote. 1/3 e to minus 2x. I'm bugging out right now. Minus 2/9 e. Yeah. Then minus 4/9i. Okay. And so I could bring that to this side, because that's already a 1, right? 1 plus 4/9 is 13/9. I is. So I think it's a good idea to factorize right now. E to the minus 2x. Change that to 3/9. So I can take out the 1/9. So I'll be left with, I took out that, right? And that, 3 sine 3x. Minus 2 cos 3x. Don't forget the plus c, but that goes. Look at that beauty. There's that 13 I was talking about before. I'm just going to write my final answer up here. I'll rub out the rest of it in a sec. So I is 1/13 e to the minus 2x 3 sine 3x minus 2 cos 3x plus c. Okay. Find the shaded area. Now, in the question that was sent to me, it just said find the exact, well, it didn't even say exact, so I'm assuming that they want me to do it exact. Now, one thing's for sure is I am not writing that evaluation into square brackets 3 times because that is just crazy long. So I'm going to... You could actually factorize out 1 over 13 from all of them. But we're basically doing 1 over 13 square bracket between minus pi over 6 and pi over 6. Then 1 over 13 between pi over 6 and pi over 2. Now we can repeat our substitutions. Then between pi over 2 and 5 pi over 6. Okay. Now the good thing about this, it looks horrible, right? But all of these values make cos 3x equals 0. So that is 0 for every single substitution. So we don't actually need to worry about it. Okay? Yes. So let me, I don't even need to double check that, but I'm so paranoid. What I would do is I'm going to write down what all of these values are now, so we don't need to think too hard about what's going on here. And sine 5 pi over 6. Oh, but we're timesing it by 3, isn't it? That's sine of pi over 2, which is 1. That's sine of minus pi over 2, minus 1. That is sine of 3 pi over 2, which is minus 1. And that's sine of 5 pi over 2, which I think is 1. Yeah. Right. Let's go for it. So we get 1 over 13. Should we just put a 3 there? Because we're going to be subbing it 3 lots of. So we get pi over 6 into here, we get 2 pi over 6, which is pi over 3, right? So we get e minus pi over 3 times pi over 6, 3. Subtract. Subbing in this one into here, you get just the same thing, but it will be e to the positive pi over 3. When you sub in minus pi over 6, you get minus 3. So should we change that to a plus and write 3? Could take out a 3 there. Might make life easier. We'll do that in a sec. Why is this question hurting my stomach, man? So subbing in pi over 2, here the 2's will cancel, e to the minus pi. Subbing in pi over 2, we get minus 3. Subtract subbing in pi over 6, which I know what subbing in pi over 6 does is this. Then subbing in 5 pi over 6. Yeah. Subbing in 5 pi over 6 with the 2 be e minus 5 pi over 3 times 5 pi over 6 gives me a positive 3 minus subbing in pi over 2 minus, right? So we're adding them all together. And to all of them, we can factorize out a 3. So 3 over 13 we have e to the minus pi over 3 plus e to the pi over 3. This one we have to be careful. It's under the axes. We actually need to make it positive. So that goes e to the minus pi and together 3 and the minus e to the minus pi over 3. Then together 3 e minus 5 pi over 3. That one's a positive area, plus e to the minus pi. So I get 3 over 13. This plus this, 2e to the minus pi over 3. That doesn't get shared with anything. This does. 2e minus pi. E to the pi over 3. And e minus 5 pi over 3. I think that's all right. Show that the ratio of the leftmost area, this one, to the central area is given by this. So basically, show that this divided by this can be written like that. All right. I'm just going to keep as much work in as I can on the board. I'll keep that over there. Now another thing we have to consider is that this I need to make positive. So let's pretend it's a whole new question and I'm dividing these. The 1 over 13s cancel, all the 3's cancel. So if I just call that A1 and A2, A1 divided by A2 is e to the minus pi over 3 plus e to the pi over 3 divided by, now I need to make both of these positive, so e to the minus pi plus e to the minus pi over 3. Now the only things that are the same in both of them is the e to the minus pi over 3, so I'm assuming that's what we're going to make 1 by dividing by e to the minus pi over 3. They cancel to make 1. When you take away the powers, you get 2 pi over 3. Here, minus pi minus minus, so minus pi minus, or plus 2 pi over 3 is minus 2 pi over 3. And 1. So there you go, gamma is, I think, 2 pi over 3. Well, that's my solution anyway. So there you go. That question is criminal. I'm pretty dead after that. I don't even know how much more YouTube I can record after this, but we'll see, guys. If you learned something new today, I would appreciate if you hit the like button, subscribe for more maths content, and if you're interested in more of my A-level courses, more details in the description. Don't forget to join the Learn Gang page, and yeah, share this with a friend who you think might benefit from this. Nice.